Okay, today's lesson is 5.1 in our book. It's graphing quadratic functions. I want to start off with a few definitions. First, what's standard form? Standard form of a quadratic function has the form of y equals ax squared plus bx plus c. Now when we graph this, the graph is called a parabola. It's a curve. The highest or lowest point is called the vertex. And the vertical line through the vertex is called the axis of symmetry. We know axis of symmetry is a line that you can fold the graph on, and the left and the right hand side would match. All right, looking at graphing in standard form. Okay, there's a few steps that we follow. Step one, we want to find the x coordinate of the vertex, and we're going to use the formula x is equal to negative b over 2a. All right, here's an example. Y equals 2x squared minus 8x plus 6. And it is in standard form. So we'll start by plugging in the values for negative b and a into the formula. So we find out the x coordinate of our vertex is going to be negative 8. Of course, you'll notice that we took the sign with the b number. Okay. It was negative 8, and that divided by 2 times the a number, and the a number is the coefficient on x squared, and that's 2. And so here we get x is equal to negative 8 is 8. 2 times 2 is 4, so we have 8 over 4, or x is negative 2. Okay? Now the next thing we're going to do is we're going to make a 5-point xy tree with x equaling 2 in the middle. Move on to the next screen. Alright, so you see I've put the XY tree right here, and I've got 2 in the middle, and what we want to do then is we want to move out symmetrically from this, and we want to move up 1 from 2 and then up 1 from 3, so we go from 3 to 4 and then down 1 and then down 2, we get 1 and 0. These 5 numbers are the numbers that we select to graph this quadratic function or graph the parabola. Okay? Now, we want to plug in 2 into our equation and find out what the y coordinate is going to be. So we put in 2 for x, and we put in 2 for x here. We square the 2, we get 4. 2 times 4 is 8. Then we multiply negative 8 times 2, we get negative 16, and of course we bring the plus 6 down. And then we work this out in our calculator, and we come up with x is equal to negative 2. So that negative 2 we'll write right here. So that we've now know that the vertex of our parabola is going to be at 2, negative 2. Now what we need to do is we need to plug in the rest of these values. So right here I'm going to plug in negative 3. Okay, so when we plug in 3, I said negative 3, when we plug in 3 for x into our equation, and we get this, and first off we'll start by squaring the 3, and we get 9. And then 2 times 9 is 18. Negative 8 times 3, negative 24. Bring down the 6. Add the positive. 6 to 18 is 24. 24 minus 24 is 0. So when we plug in 3, we get 0. All right? Now let's plug in 1 into our equation. So we get y is equal to 2 times 1 squared minus 8 times 1 plus 6. Okay, we squared the 1 and we got 1. 2 times 1 is 2. Negative 8 times 1 is negative 8. Bring down the plus 6. Add our positives. 2 and 6 is 8. 8 minus 1 is 0. We find out when we plug in 1, we get 0 as well. Okay, let's plug in 4. So we get y is equal to 2 times 4 squared minus 8 times 4 plus 6. Okay, we square the 4, we get 16. 2 times 16 is 32, minus 8 times 4, or negative 8 times 4, negative 32, plus the 6. If you want to add the positives, you get 38 minus 32, or 6. So we get 6 when we plug in 4. Now let's plug in 0. So we have y is equal to 2 times 0 squared minus 8 times 0 plus 6. This one's not going to take very long. We get 0 minus 0 plus 6. We get 6. Okay, so I want to take a look at this chart now and recognize something that's going to always be true when you pick your numbers, as I've shared with you right here. Put the x-coordinate of the vertex in the middle, go up one, go up another, go down one, go down another. Then what we find out, because parabolas are symmetric or symmetrical, that these two are always going to be the same, and these outside two will always be the same as well. So when we're doing this from now on, we're only going to choose one of these. We'll do it, we'll plug it in, and then we'll just automatically write the other one in because of the because parabolas are symmetrical. It's not a very good picture of one, but if you're at the vertex and you move out the same distance from the vertex, it's going to be the same distance up to the graph. In other words, these would be at the same height, and if you moved out 2 units, then they would be at the same height as well. So it's because parabolas are symmetrical that we can count on this being true every time. Okay. All right, next we're going to graph this. So we've got the chart right here, and I can see I've got a number that's wrong here. That should be 6. Let me just go ahead and change it to 6. And so we'll graph these points. So we have the point 0, 6, which is going to be, let me move this out of the way. It's going to be right here, 0, 6. And we have 1, 0. We have 2, negative 2. We have 3, 0. And we have 4, 6. All right, now what we want to do is attempt to draw a curve through this. Now let me tell you, don't connect them with straight lines because it's not a straight line. It's not all that easy to draw, but if you can imagine the tip of a bullet, then that's sort of the shape that we're looking to make here. And I'm not doing a very good job with this software. If this was the chalkboard, I could do a lot better, but that is absolutely terrible. Anyway, this should go down through here. Okay, so it should take on the shape of what would be the tip of a bullet or something like that. All right, the next thing we want to do is to draw in the axis of symmetry, and that's going to be x is equal to the x-coordinate. So this equation right here, x is equal to the x-coordinate. Now if you remember, this is a vertical line. All vertical lines start out with x equals. And so what we do is we dot in this line right here, this axis of symmetry. This is part of graphing. And we label it. So this is up at top here. I'm going to label x is equal to 2. And then that completes this graph. Okay? All right. Let you try this one. I'll pause the video and we'll come back and look at it. Okay, step 1 is going to be find the x-coordinate of the vertex, so we'll use negative b over 2a. So we have negative, and then the b, remember there's a number in front of this. I'll kind of dot it in because it's there, but it's not written in. So that's the negative 1 over 2 times a, and the a is going to be that number right there, 1/2. Okay, so negative 1 is 1. And then 2 times a half, if you want to see these as fractions, the 2's will cancel. You get 1 over 1, which is 1. So our x-coordinate is 1. Then we're going to go up 1 from that, 2, and then 3, selecting our x values, 0 and negative 1. So let's plug in the first one. Y is equal to 1/2. Let's plug in 3. 1/2 times 3 minus 3 minus 6. Okay, so we're going to square the 3. We get 9. I write it over 1 since I'm multiplying by a fraction. Numerators times numerators, 9. Denominator times denominator, 2. Minus 3 minus 6 is negative 9. Now I'm going to write 9 as halves. 9 is equal to 18 over 2. So I have 9 halves minus 18 halves, or negative 9 halves. And that's going to give me negative 4.5. So for 3, it's negative 4, and I'll just use a decimal since I have a an equivalent. Now, we remember that this and this are going to have the same answer. No need for us to work both of them. Negative 4.5 goes down here as well. Okay? All right, let's go ahead and erase this. And do the next one. All right, so we're going to plug in 0 now, because 0 looks like it'll be really easy to plug in. So I have 1/2 0 squared minus 0 minus 6, and of course that's 0 minus 0 minus 6, and that just gives me negative 6. So when I put in 0, I get negative 6, and I put in, it's also going to be negative 6 here. Okay, now well, I usually do this one first, but it looks like I kind of left it off, so we'll come back and do this one next. All right, so let's do find the x-coordinate of the vertex. A little out of order here, but it's all right. So we have y equals 1/2 1 squared minus 1 minus 6, 1/2 times 1 minus 1 minus 6, 1/2 minus 7, 1/2 minus 14 halves, negative 13 halves, negative 6.5. So we have negative 6.5 here. All right. All right, the next thing we do is we graph these. All right, so let's find these points. Let's see. So we'll start with 3. So go over 3, and we're down at negative 4.5. 1, 2, 3, 4.5. That's a point on our parabola. All right, negative 2 and 6 is on our parabola. 1 and negative 6.5. Now, it's just a little bit off of the graph here, but that's going to be about right there. It still works. 0 and negative 6. And then negative 1 and 4.5. All right, so this one might look a little bit nicer than that last one. And just really struggling with this software to be able to draw a curved line here. All right, that's going to keep on going. And I'll connect those, and this one keeps going up here. Dot in the axis of symmetry. It's a vertical line through the vertex. Label it x equals 1. It's always going to be x equals this right here. Axis of symmetry. All right, well, let's move on. All right, now we're going to talk about graphing in vertex form. Vertex form is in this form: y equals a parentheses x minus h squared plus k, and it has a vertex at hk. Now let me point out a few things. That the h in our problem and the h in our vertex, well, here it says minus h. If you look at that subtraction as a minus sign, you get negative h, and here you have positive h. Okay, now I said down here we say that h always lies, and what I mean by that is that the sign in our problem and the sign in the vertex are always opposite. Now, it's not to say that this one's always negative and this one's always positive. What we can glean from this, where this is negative h and this is h, is that they always have opposite signs. And if we look at the k, we have positive k here, and of course we have k without a sign, and of course we know without a sign it's positive. So what we say then also is that k always tells the truth. H lies, they're always opposite. K tells the truth, they're always the same sign. And again, it's not to say that they're always positive, but that they're always the same sign. Okay, so in our example here, we're going to look at negative 1/2 x plus 3 squared plus 4. And the first step is going to be to find the vertex. I usually like to write it right underneath there so I can see the opposite signs with h, and then the same signs positive, no sign makes it positive, with k. All right, I've gone ahead and worked this one out. I went ahead and put the vertex in to start with. All right, and then what we would do to find these other values is we take -4 and we would plug it in right here and we'd work that out. Okay, so I've gone ahead and worked this out. That's just plugging in numbers and following the order of operations. That's not necessarily something that we need to practice every time. So we'll go ahead and go to graphing this one. So we have -3 and +4. That's the vertex. That's going to be the highest or lowest point. And I didn't go to, okay, negative 3 and 4. -3 and negative, let me get this straight. -3, +4, I've done my vertex. -4 and 3.5. Okay, so here we go right here. 2 and 3.5. -1, and we're at 2. And over here at 5, we're at 2. And just try to do this a little bit prettier than it's been being. I'm really not happy with how I can draw a curved line with this software here, but we'll make an attempt trying to make these curved. And then we dot in the axis of symmetry. That's the line where if you fold it on this line, the left and right hand side match, and we label the axis of symmetry. It is a vertical line. All vertical lines start with x equals, and then it's going to be x equals -3 is the vertical line. That's the axis of symmetry. Okay? All right. Let's get you to try one. I'll stop the video, let you have time to do this. Okay, so step 1 would be extracting the coordinates of the vertex from the problem. H always lies, K tells the truth. Same opposite signs with X and the same sign with Y. So we plug that in. And we choose our points. So we're going to go up 1 and up another. Subtract 1, 1 from 1 is 0, and then go down another. All right. And we're going to plug in these numbers. We don't have to plug them all in. But let's start with 2 this time. So we have 2 times 2 minus 1 squared plus 3. 2 times 1 squared plus 3. 2 times 1 plus 3. 2 plus 3. We get 5. 5 goes here. 5 also goes here. Okay, let's plug in 3. So we have 2. 3 minus 1 squared plus 3. 2 times 3 minus 1 is 2. Following order operations, 2 squared is 4. 2 times 4 is 8 plus 3. We get 11. 11 goes here, also up here. Let's graph these. Okay, looks like I'm going to go off the graph just a little bit, but I think we can probably figure out where it goes. So we have 3. Now this would be 10 right about here. So 11 is going to be up here. So that's going to be a point on my parabola. 2, 5 would be a point right here. 1, 3, the vertex. 0, 5. And -1, 11, and I guess I'm going to put it about right there. Okay, and then an attempt at making a curved line. Maybe I'm getting a little better with this software. I don't know. I'm better in real life than I am on this thing. That left-hand side always gives me trouble. I start to wander. Sorry about that. So that should be more. Trying to make a curved line here. I apologize for the sloppiness there. Axis of symmetry, we draw it in and we label it. Its x is equal to 1. Okay? And that's graphing in vertex form. All right, the last one, last form, is graphing in intercept form. Intercept form looks like this. Y equals A, and then x minus p, parentheses, x minus q. You can look at it as being that trinomial is being factored into 2 binomials, with this being, say, the coefficient of all of it. All right, so the x-coordinate of the vertex when it's in vertex form is found by p plus q over 2. Let's note that p and q are opposite signs. Just like h in the vertex form, we have minus p up here, but we have positive p in our little formula for the x-coordinate. Negative q up here, positive q in our formula. So we have to remember that those are going to be opposites. Okay, and the parabola has x-intercepts at x equals p. Again, they're opposite from what they are in the problem here. Whatever this is, whether it be plus or minus, this is going to be the opposite, and x is equal to q. Again, the opposite. Signs of p and q are opposite from those that are in the equation. All right, we graph with only 3 points this time, so actually this is a little less work and when it's in intercept form. The vertex and the 2 intercepts is what we use. Okay, let's take a look at one. So remember that the number in front here is going to be 1. It's not necessarily written in, but y equals negative, and then parentheses x plus 2, x minus 4. So we want to find the x-coordinate of the vertex, so we're going to use our formula. I wrote it down here. Now you'll see that I've got the opposite of p and the opposite of q here from what they are in our problem. So I have negative 2 plus 4, and that adds up to be 2. 2 divided by 2 is 1. Now we're going to plug that back into our equation up here. So we put 1 in for x, and then 2 plus 1 is 3. 1 minus 4 is negative 3. With the negative on the outside, we have negative 3 times negative 3, or 9. And the coordinates of the vertex are 1, 9. All right. So with 1, 9 and the 2 x-intercepts, now remember it was x is equal to negative 2 and x was equal to 4. Now what I've done right here is I've put those in ordered pair form. So if the intercept is at negative 2, that's the ordered pair negative 2, 0. And if it has an x-intercept of 4, well, of course the ordered pair for that would be 4, 0. Okay, so we come down here to the graph and we find these 3 points. So 1, 9 is right here. And then my x-intercepts, where it crosses the x-axis at negative 2 and at positive 4. Now, the other points that we had on the other forms, we had 2 of them that were sort of close to the vertex that we're not including with this method here. So we've got to make sure to come out a little bit before you start coming down. Man, I can really criticize the way I'm drawing curved lines on this software. I don't like it at all. These are supposed to be smooth curved lines, and I just can't get it going here. So we draw our parabola in, and then we put in our axis of symmetry. It's the vertical line through the vertex, and then this is x is equal to 1. Okay, and let's try one of these. Give you some time to do this. Okay, so x is equal to p plus q over 2. The opposite of negative 3, 3. The opposite of positive 1, negative 1. 3 plus negative 1 is 2. 2 divided by 2 is 1. That's the x-coordinate. So I've got that right here, 1. And we take 1 and we plug it in for x into our equation. So we have 2 times 1 minus 3 times 1 plus 2. Well, 1 minus 3 is negative 2. 1 plus 1 is 2. So we have 2 times negative 2 times 2. That gives us negative 8. That's our y-coordinate of our vertex. We just write these down because we can extract them straight from the problem. So it's going to have x-intercept at the opposite of this, 3, 0, and the opposite of 1 is negative 1, 0. Now we graph these. So we have 3, 0. We have negative 1, 0, our x-intercepts, and our vertex is at 1, negative 8. And then we do our best to draw a curved line through here. Gee whiz. This is absolutely terrible, but it's all I can do on this software that I have. Now, those should be smooth lines, class. I apologize. I'm just not able to do it today. And then the axis of symmetry, the vertical line through the vertex. And label it x is equal to 1. Okay? All right, so that's graphing in intercept form. That's actually a little less work. All right, next thing I want to talk to you about is the effects of A. Now I've got all the three forms written out here, and as you can see, they each have an A in them. And what I want you to realize, and this is a lot like what we did when we did absolute values, is that if the absolute value of A is equal to 1, then the parabola is what we call A of normal width. Now, if that number is, the absolute value number is greater than 1, a number like -3 or +3 in front here, then the parabola turns out to be a more narrow parabola. And if the absolute value of A rather, is greater than 0 but less than 1, and numbers like that would be like, 1/3 or -2/5 or -9/10, that's even less than 1, then it turns out to be wider than normal. And the other thing about A is that if A is positive, we know it opens up. It would be one like this. And if A is negative, it opens down. And so those are the things that we can learn from the A in front. Okay? The last thing that we're going to do in this section is we're going to be changing from intercept form to standard form. And I want to do one of those. So remember, standard form is y is equal to ax squared plus bx plus c. Okay? Well, in intercept form, we've sort of got it factored out. So really what we have to do is we have to just multiply it all together and collect like terms. I'll go ahead and write the 1 in here. And let me suggest that you do the binomials first. So multiplying the binomials, we have first times first, or x times x, and that gives us x squared. And that's first times first. Then outside, this is the FOIL method, or x times -9, and I have -9x. The inside, positive 4 times x, and I have positive 4x. And then last times last, or 4 times -9, and we have -36. Collecting like terms in here. -1 times x squared. A -9 and a positive 4 is not -5x minus 36. And then multiplying through by the -1, we have negative x squared plus 5x plus 36. And we have changed it from intercept form to standard form. Okay? Go ahead and try this one. Okay, so when we multiplied the binomials, first times first was x squared, outside gave us -5x, inside gave us positive x, and last times last, 1 times -5, -5. Adding the like terms, -5x and x add up to be 4x. Multiplying through by the -3 times x squared, -3x squared, -3 times -4x, positive 12x, -3 times -5, positive 15, and we've changed it to standard form. Okay? All right, one last example, and that's going to be from vertex form to standard form, and this is very similar to the last problem, where the only thing we're going to do here is knowing that squared means something times itself. Well, then we'll just simply write that binomial out twice, and we'll do the order of operations. We'll multiply the binomial, so we have first times first, or x squared, outside -x, inside -x, last times last, positive 1. Collecting like terms, x squared minus 2x plus 1 plus 8. Multiply before you add, so we're still following the order of operations. Multiplying through by 3. 3x squared minus 6x plus 3 plus 8. Now add the constants, 3x squared minus 6x plus 11. All right, you try this one. All right, writing the x plus 2 out twice and multiplying x times x squared. Outside x times positive 2, positive 2x. Inside 2 times x is 2x. Last times last, 2 times 2 is 4. Collecting the like terms here, we get x squared plus 4x plus 4. Distributing the 1/2 x times x squared is 1/2 x squared. 1/2 times 4, 2x. 1/2 times 4 is 2, and then 2 and negative 3 gives us the final answer of y equals 1/2 x squared plus 2x minus 1. All right, well, that concludes this video, and I'll make the assignment for the class, and see you next video.